All right, this is the second part of lesson 3.7. We're going to do the got it, and we're going to solve this absolute value equation. What are the solutions of the absolute value of the quantity 3x minus 7 minus 6 minus 5 equals negative 7? To isolate the absolute value expression, you would add 5 to each side of the equation. Circle the simplified value of the right side of the equation. So if we take negative 7 plus 5, we get negative 2. And I think we're done here solving, because we know that the absolute value of a number of an expression cannot be negative, so the inequality has no solution. All right, key concept, solving absolute value inequalities. To solve an inequality of the form the absolute value is less than b. That means that A is somewhere between negative b and b, so to have a distance from the origin to be equal or less than b units. So somewhere in this range, the distance from the origin is less than b units away. You have to remember with absolute value, you can be left to the left of 0 or to the right of 0 and be that distance away. For the absolute value of a to be greater than b, that means that a must either be greater than b units away from 0 or less than negative b units away from 0. So we will, for the first one, we're going to have to solve this compound inequality to find all the solutions. For the second one, we're going to have to solve a compound inequality like that, find all the solutions. All right? So if we're going to solve the absolute value of 5x is greater than 3, that means 5x is either greater than 3 units away from 0, or it is less than negative 3 units away from 0. So in other words, on a number line, it's like this. Out here we have 3, out here we have negative 3. The solutions, the 5 times x is either out here, an open circle, or it's over here. So it's either greater than 3 units to the right of 0 or greater than 3 units to the left of 0. All right, so the compound inequality we would use would be 5x is less than negative 3 or 5x is greater than 3. That's that inequality. Okay, if we're going to do 3x is less than 5, that means that 3x is somewhere in this range on a number line. If we put 5 here, and we put negative 5 here, 3 times x has to be somewhere in that area with an open circle on both ends to be less than 5 units from 0, which means 3x is less than or greater than negative 5, and at the same time it's less than 5 units from 0. So that would be this inequality here. All right, so let's try a couple of those problems. What are the solutions of the absolute value of 5x is greater than or equal to 20? So this distance, 5 times x, has to be greater than or equal to 20 units from 0. All right, so that would give us values like this. If we either 5x is greater than or equal to 20 units from 0, so that's all those, that'll be a bunch of positive numbers, or 5x is less than or equal to negative 20. That will give us 20 units to the left of 0. When we solve this, if we divide both sides by 5, we get x is greater than or equal to 4, or x, if we divide both sides of this by 5, we get x is less than or equal to negative 4. So if I graph those, x is greater than or equal to 4. That means numbers like 5, 6, 7, and so on. And if I graph x is less than or equal to negative 4, that would be numbers out here. Now, if you think about those numbers, like negative 5 out here, if I put negative 5 into my original inequality, so in other words, if I do 5 times negative 5, 5 times negative 5 has to be greater than or equal to 20. And I have a question mark here because I'm not sure. I'm just testing this. All right. Well, 5 times negative 5 is negative 25. And the absolute value of negative 25 is positive 25, and that is definitely greater than or equal to 20. So you see how negative numbers to the left of negative 4 will give us a positive value that's greater than or equal to 20. And likewise, if I try numbers out here like 5, if I do 5 times 5, put that in the original inequality and just see if that is greater than or equal to 20. So that's question mark. I get the absolute value of 25 is greater than or equal to 20. And the absolute value of 25 is 25, and that sure is greater than or equal to 20. So those solutions work. All right? So I got it here. What are the solutions of the absolute value of the quantity 2x plus 4 is greater than or equal to 5? Graph the solutions. That means that my 2x plus 4, that number inside the absolute value, must either be less than or equal to negative 5, or it has to be greater than or equal to positive 5. Less than or equal to negative 5 would put me out on the number line to the left of negative 5. So those numbers are more than 5 units from 0. So, and numbers that are greater than or equal to 5 are also more than 5 units from 0. Okay, so we're going to solve these inequalities. So 2x plus 4 is less than or equal to negative 5. 2x plus 4. Subtract 4 from both sides, and we get 2x is less than or equal to negative 9. Divide both sides by 2, and we get x is less than or equal to negative 4.5. Or we have 2x plus 4 greater than or equal to 5. That would mean that 2x, if we subtract 4 from both sides, is greater than or equal to 1. And if we divide by 2, that would mean x is greater than or equal to 1/2. So numbers, at least we think, numbers like that are greater than 1/2, so greater than or equal to 1/2, so that would be numbers out here. We'll solve this, and so will numbers like that are less than or equal to negative 4.5, so that means numbers like this. All right, so, and to just check that, see if we're right, we saw a number like negative 5 in the original inequality, which is the absolute value of 2x plus 4 is greater than or equal to 5. If I put negative 5 in there, so I'm doing 2 times negative 5 plus 4, I'm hoping that that will be greater than or equal to 5. So I have negative 10 plus 4. And negative 10 plus 4 is negative 6. And the absolute value of negative 6 is 6. And 6 is greater than or equal to 5. So that checks. And on the other end, if I pick a number out here, like say 1 or 2, I'll pick 2, and I put that in this original inequality, so I did 2 times 2 plus 4 absolute value of that, and I hope that's greater than or equal to 5. And 4 plus 4 is 8. And the absolute value of 8 is 8, and 8 is greater than or equal to 5. We're good. All right, so here's the problem. All right, so this athlete normally runs 1 mile in 224 seconds. An athlete wants to run within 6 seconds of his normal time. What is the range of allowable times for that? In other words, the difference between his time and his normal time, we want that to be less than or equal to 6 seconds, within 6 seconds. So we're going to use that inequality, less than or equal to 6. And the way we're going to get that difference in time, that can either be a positive or a negative number depending on whether the athlete runs less than 224 seconds or more than 224 seconds. So we're going to use an absolute value. So whatever time he gets, we'll let t be the time he gets on any race. If we subtract 224, that could be a positive or a negative number, and we want it to be a positive number. So to make sure that happens, we're going to use the absolute value here. And then when I do that, I end up with 2 inequalities that I need to solve. So my t minus 224 can either be less than or has to be less than or equal to 6, and t minus 224 has to be greater than or equal to negative 6. So you can see the 2 possibilities here. We might have a negative number or we might have a positive number. If I solve this side, if I add 224 to both sides, I get t less than or equal to 230. And 3 is, if I add 224 here, t is greater than or equal to 280. Okay? So the athlete wants the time to be between 218 seconds and 230 seconds. We can write that as a compound inequality. All right, so let's check this one out. Food manufacturer makes 32-ounce boxes of pasta. Not every box weighs exactly 32 ounces. The allowable difference from the ideal weight is at most 0.05 of an ounce. Right? And solve an inequality to find the range of allowable weights. So we're going to write W, the absolute value of W minus 32. So in other words, the difference between the weight, the actual weight, and the weight the manufacturer wants is at most 0.05. All right, and that inequality represents that. So the absolute value inequality as a compound inequality would look like this. Negative 0.05 is here's the compound inequality. Now we would have to add 32 to each of these parts, and it's okay to use the addition property of equality this way with the compound inequality. So we get 31.95 is less than or equal to W is less than or equal to 32.05. So a box of pasta must weigh between 31.95 and 32.05 ounces. I have to end the video here. I'm running out of time, but I'll quick put up the answers to the lesson checking. Have a good weekend.